This is the physics of an egg drop. For this experiment, you need a large drinking glass, a cardboard tube, a pie pan, eggs, and water. First, you take your large drinking glass and you fill it 3/4 of the way with water. Next, you take your pie pan and you place it on top of your drinking glass. Then, you take your cardboard tube and place it directly over the water. Then you carefully put your egg on top. Now, I'm going to smack the pan out from under the egg, but the egg won't fly with the pan, it'll drop in the glass of water. Why does the egg fall in the glass, you ask? I'll tell you. Notice how the egg falls right into the glass? This is because a few forces are at work, such as gravity and inertia. Gravity is a force all over the universe that keeps us on the ground. Gravity is the reason that when you throw something in the air, it comes back down instead of just floating away. Gravity is the force that keeps all the planets in orbit around the sun. Without gravity, the planets in the solar system would just fly off into outer space. Even though gravity is all over the universe, Earth has its own gravity. Gravity on Earth always pulls toward the center of the planet. So no matter where you are on the Earth, gravity always pulls in the same direction, down. The first man to teach us about gravity was a scientist named Galileo Galilei, who lived around 1590. He climbed up the Leaning Tower of Pisa and dropped some balls to the ground. Two balls of different masses, but of similar shape and density, were released together, hit the ground at the same time. Until then, it was commonly believed that heavy things fall faster than light things, but this isn't the case. The speed or acceleration at which things fall depend on their relationship with gravity. The heavier the object, the more mass it has, which affects the acceleration, but they all fall proportional to the gravity. Gravity is the force that causes the egg to fall into the glass in an experiment. The experiment will also work with something like a coin. As long as you pull the dollar out fast enough from under it, the coin will fall into the glass, no matter how small the opening. Another scientist that contributed to studies on gravity was Sir Isaac Newton. He learned a lot from the studies of Galileo. Newton is also known for what we call Newton's laws of motion. The first law, Newton's law of inertia, is every object in a state of motion tends to remain in a state of motion unless an external force is applied upon it. Since the egg is not moving while it sits on top of the tube, that's what it wants to do, not move. We applied enough force to the pie pan to cause it to zip out from under the cardboard tube because there's not much friction against the drinking glass. The edge of the pie pan hooked the bottom of the tube, which then sailed off with the pan. Basically, I knocked the support out from under the egg. For a brief nanosecond or two, the egg didn't move because it was already stationary. But then, as usual, the force of gravity took over and pulled the egg straight down toward the center of the earth. Also, according to Mr. Newton's first law, once the egg was moving, it didn't want to stop. The container of water interrupted the egg's fall, providing a safe place for the egg to stop moving so we could recover it unbroken. The gravity-pushed egg caused the water to splash out. Here's another cool experiment you can try.
To start this experiment, you will need a tall glass with round edges, a handkerchief of some sort, a pitcher of water, and a bowl or sink in case the experiment fails.
First, drape the handkerchief over the glass, making sure that you push the center of the handkerchief down into the glass. Next, fill the glass 3/4 full with water by pouring water into the middle of the handkerchief. Slowly pull the handkerchief down the sides of the glass, making it taut, stretch tightly across the surface of the glass. Grip the ends of the handkerchief at the bottom of the glass. Place one hand over the mouth of the glass and turn it over with the other hand. Pull the lower hand away from the glass, and the water should stay in the glass. This just goes to prove that the handkerchief was anti-gravity properties. Most people predict that the water will leak through the holes in the handkerchief because the water leaked through the holes as it was poured into the glass. The holes in the handkerchief literally disappeared when the cloth was stretched tightly across the mouth of the glass. This action allowed the water molecules to bond to other water molecules, creating what is called surface tension. The water stays in the glass even though there are tiny holes in the handkerchief because the molecules of water are joined together to form a thin membrane between each opening in the cloth. Even though this has almost nothing to do with gravity, it was still cool to see how the laws can sometimes be defied. If you're feeling super confident in your abilities, grab some more eggs, some more tubes, and more glasses. So this is my attempt at getting 2 eggs at the same time, and here we go. This time, when you put the tray on, make sure that the tubes line up with each one of the glasses. Just like before, put your eggs in the tubes. And again, slap the pan out from under. I broke an egg.